next up, we have a very special guest as well, Ms. Jessica Talisman. And for those who don't know, has anyone heard of this incredible person before? Lots. Okay, I see hands. Yes. So for those who don't know, this brilliant architect. So Jessica Talisman is an information architect, all right? Information architect, a semantic strategist, a lifelong student of systems, meaning, and human understanding. And for over 25 years, she has worked at the intersection of knowledge, of frameworks, of digital infrastructure, and helping both large organizations and cultural institutions build information systems that support clarity, interoperability, and long-term value. So we are thrilled to have Ms. Jessica Talisman join us today for a conversation on context graphs, and context specifically is knowledge. So before we get started, because I see things are still developing over here, what I want you all to do is to, we actually are ready to get started. All right, so next time I'm gonna have some networking questions for you all. All right, so let's give Jessica a round of applause, everyone. Thank you.
Thank you so much. So it's been quite a whirlwind in, less than 2 months, we all of a sudden have context graphs. And so it just so happens that around 3 months before the context graph article published, I had been doing research and written a paper about process knowledge management. Not sure if many of you have heard of that. It's process knowledge and procedural knowledge, which is essentially context graphs. So I will be a little tongue-in-cheek about this, because when we say context graph, it's like saying wet water, because that's the benefit of graphs. But I have been working for about 25 years in the semantic space, specifically with knowledge graphs. I'm a librarian by training, informatics, and also teaching. I've worked in enterprises for the better part of 25 years, but I've also spent some time, thankfully, in GLAM, cultural institutions, which I think is a nice offset and balance. So let's get started. In December of 2025, Foundation Capital published an opinion piece, mind you, a blog, that sent ripples throughout enterprise software circles, and the title alone did the work: Context Graphs, AI's $1 trillion opportunity. So the argument was clean and seductive, the single most valuable asset for companies in the era of AI. It was the $1 trillion and still is postured as the $1 trillion opportunity. So the argument was clean, it was very seductive. Enterprise systems like Salesforce, Workday, and SAP have spent decades recording what happens, so decision traces are not new. The one thing that was interesting that kind of changed the trajectory, at least from my vantage point when I started examining the blog, there were no proofs of concept. There was no explanation of how this is done. There was no demos, which was a wonderful opportunity for the entire technology industry to basically have fun, have a play day, start to innovate, start to decide what this means and how it should manifest in a system. The quote, "the single most valuable asset for companies in the era of AI," left a lot of room for creativity and a lot of opportunity for new products to emerge. So they named the problem, and it's a problem many of us have been facing, and I agree with the problem. The urgency is there. And what I want to challenge tonight is the solution, because the framing Foundational Capital uses carries a hidden assumption that if left unchallenged will cause every context graph initiative to fail for exactly the same reason that most AI initiatives have been failing. And that is mostly, just to put it into your ear, that this is a knowledge management problem. It's not something that it can exist in isolation. It is a knowledge management problem. The hidden assumption exists in the single sentence, and let me read it to you carefully. The wall isn't missing data, it's missing decision traces. That sentence sounds like a solution, and most of us took it as a solution, that decision traces are the solution, but it is in fact a misdirection, because decision traces are not data. Decision traces are knowledge, or part of knowledge. As we just saw in Will's demo, he had to connect the decision traces to other context, other meaning, the actual knowledge within a system. I thought that was beautifully presented, was it could not live or exist in isolation. Capturing knowledge is not an engineering problem that you solve by instrumenting an orchestration layer. It is a knowledge management problem, one that requires entirely different methods, disciplines, and infrastructures. I'm going to show you where the context graph thesis is right and where it goes sideways and what the actual foundation needs to look like, drawing from Process Knowledge Management series and some of my ontology work that I've been doing in the process. So the straw man, we're going to work this out in terms of, to understand the argument fully, is there some things that the argument has correct? Yes, current state systems preserve the outcome, not the reasoning. And I think Will also just presented that. You can't replay the state of the world at decision time. We can agree. Warehouses are in the read path. We can agree. Agents have structural advantage because agents sit in the orchestration path. We can agree. The claim I'm challenging is that it's not a data problem. It's not a data problem and it's not an orchestration problem. It is a knowledge management problem. And this came through in my research and work with the Sufrail group, with the procedural and process knowledge management work. Something has to define what a decision is. Something has to model the entities, the relationships, the roles and exception policies, and conditions that give a decision its meaning. That something is not a database. It is a knowledge model. That's why we call it a knowledge graph. Here's the claim I want to put in front of you directly, which is Foundation Capital says it's not a data problem. I say it's not a data problem, and it's not an orchestration problem. What I'm posing to everyone in the room is that it's a knowledge management problem. Context is not the same as data. Context is meaning derived from relationships. So when a VP, I think this was in the essay, when a VP approves a 20% discount that exceeds policy by 10%, what makes the decision comprehensible? Well, obviously you would need the facts that surround that decision that makes that thing true. And that's what we see with ontologies and knowledge graphs. So we don't get this simply by capturing a logged event or by logging an event. It is captured by having previously defined in a structured way what customer tiers exist, what policies govern discounts, what roles exist in approval hierarchies, what outcomes are possible, and how exceptions relate to precedents. So I'm not sure how many of you have heard of Polanyi's paradox, which is we know more than we can tell. And the thing, I wish this microphone were portable, guys. I'm like trying to walk away from it, but I won't. That tacit knowledge, the thing about tacit knowledge is that it's something that exists in people's heads. And I've joked that we would have to employ Neuralink for us to in fact capture tacit knowledge, because once knowledge is recorded, it's no longer tacit. That's just a social condition. The thing about knowledge management also is that knowledge management is also a very social process. It invariably involves humans. So if we're going to make decision traces queryable, if we're going to make precedents searchable, we need to do three things that Foundation Capital's framing does not account for. So it's called knowledge elicitation, which is the elicitation of tacit knowledge that, oh, thank you. That, is it on? Yes. That is the elicitation of tacit knowledge that determines a decision, even what a decision is. Thank you, and what makes it meaningful. So the idea is to organize and to encode this knowledge in a meaningful way to create the relationships and connections between things. So we need to encode it in a formal representations that computational systems can in fact reason over. So the interesting thing when we look at context is a lot of context, and again, we saw this in the demo that we just witnessed with Will, is that context and meaning are derived from relationships between things. That's just the nature. It's the space in between, the negative space between nodes, the ideas of how things connect, and those decisions. So the types of things that we see, event logs, facts, without structure, that can fit into sort of the data column. When we look at knowledge, we're modeling facts with relationships and we're applying formal definitions. And when we get to context, we're deriving the meaning from the relationships over time. That's where the context comes into play. So when we look at how we can architect and engineer process and procedural knowledge for context to derive context, in my series, my process knowledge management series, I broke this into 3 layers. One is strategic. So there is an actual act in knowledge management, in the elicitation and the recording of knowledge, where we question, why does this process exist? What value does it create? Because we have to actually define what we're modeling. That's just practical, that's pragmatic. The second is tactical. We look at bottlenecks, resource allocation, exception handling, and optimization. So that's the tactical layer. And the third layer is operational, which was most of the focus of Foundation Capital's thesis and most of the focus of most context graphs that I'm seeing is the operational piece. It's the top layer. So again, we are jumping to the final result rather than doing the work that's necessary to actually encode this as knowledge so that we can build resilient systems. So the pragmatic aspect of context graphs is that there's no way that you can query what you don't understand. There's no way to query what you haven't represented formally. And there's no way to query across systems, especially when you have multiple workflows at play. It's not one size fits all. That's just a matter of fact. We've experienced this before. It's like Groundhog's Day. We've been here before with other systems. And here we are with AI systems, again, hoping that we can magically render knowledge with the help of AI systems. And this, fortunately or unfortunately, involves humans in the loop. So I'm sort of rushing through this so that we can save time, but what does a knowledge infrastructure look like? And this was so interesting from my research with the Cephriel group and with the procedural knowledge. So this was a 3-year-long project, and they actually have white papers and peer-reviewed papers, and formally these things are not called context graphs. The paper that Will brought up was a knowledge graph, but it wasn't context graph in the traditional sense as we know it now of recording decision traces. Traditionally in knowledge management, context graphs are in fact known as procedural knowledge, but that doesn't sound as sexy for marketing, so we'll go with context graphs. So with procedural knowledge, you're documenting procedures. This is a representation from the PKO, which is the Procedural Knowledge Ontology. Most people are allergic to the word ontology. You could transform something like this into a schema if you're working with relational databases. Either or. The most important thing is that you have a methodology for actually recording the different stages and processes of knowledge. So we know, and this is the most interesting thing about procedural knowledge, is there's a before and after. So before things are recorded, that tacit knowledge that we talk about is in fact called process knowledge. Once it's recorded and no longer tacit, it becomes procedural knowledge. Process knowledge becomes procedural knowledge. In so doing, when you're organizing the raw material, when you're collecting or elicitating the raw tacit knowledge from people's heads, remember we're extracting it from people's heads, is then once it's recorded and it's encoded and organized and it becomes that encoding layer as ontologies, that's when we have the proof point, which is the procedural knowledge ontology, which is able to capture every single step in a workflow from execution traces to decision traces. The one thing that came true from their research, and this was for their peer-reviewed research and studies and white papers, they did a large-scale study with Siemens and their electric grid. And they were able to document across a very complex electric grid system across their factories to determine down to the millisecond when a system needed to switch over from one grid to another. That was one of the outcomes. Another one was with Belco in the EU, which had to do with lockout tagout. And that happened to be one of my favorite studies and papers, because when you actually bring procedural knowledge and context graphs into the real physical world, the story changes. When people's lives are at stake and you actually have procedures and processes that are with AI assistance. By the way, all of the things in the PKO research was with real industrial experiences and systems. So when actual humans' lives and well-being are at stake, you really see the impact of something like this system, procedural knowledge. So through the research, what came out with Beko, Fager, Siemens, and through the EU for their own internal systems, what they found was that 70% of their data analysis, this is specifically with Bosch, with their knowledge graph and with the procedural knowledge, that they were able to save about 200,000 euros a year. And this was simply by documenting these workflows, but the key was not simply creating what we call decision traces or the procedural knowledge or the context graph or that simple stream of data of the reason what and why these decisions were made, but it was actually having that knowledge encoded and represented formally within systems so it could be drawn upon and expanded upon, maintained throughout time. So when we look at how we can ground these, this type of system, the idea of a context graph, how we can take that into the real world and actually implement something that's reliable, the one thing that I suggest, and perhaps that's why I'm here, is to actually look at the prior art, to look at the research that's already been done, to realize that this is an established domain of study, research, and practice, that this idea, this concept has just not emerged out of the blue. It's something that we're kind of losing in this age of AI, where we are losing the citations, we're losing the prior art, we aren't standing on the shoulders of giants. And that perhaps is one of the greatest opportunities of context graphs, is actually being able to draw upon the expertise that has existed for years, the research that has existed for years. So there's 4 things that I think, personally, that organizations need to do. The first is to acknowledge that it's a knowledge management problem, because without realizing it's a knowledge management problem, then we're just going to be collecting streams of data and hoping for the best. So there is that factor of needing to manage our own knowledge, and I feel like that's the elephant in the room we've all been avoiding. It's hard work to manage knowledge, to keep your documentation tagged, to be able to organize things and label things and describe things and define things. The next is to build, to invest in elicitation infrastructure. So we talk a lot about wanting to automate everything and that somehow we're just going to manifest knowledge out of systems, but in fact, there's a human factor to this. And so part of that is involving humans in the process and recording that knowledge. So that's the second part. And there's methodologies in my papers that tell you how to do that, and it can be quasi-automated. The third is to build the knowledge model before the persistence layer, and that's critical. So you define what a decision is in your domain, you model entities, roles, conditions, policies, and this becomes part of your ontology or your knowledge representation. So don't put the cart before the horse. And the fourth is design for knowledge capture as a primary objective. So things like building prompt libraries, that's something I don't see a lot of people doing. Central registries, formal representations, you make the entire AI proposition about process, procedure, and knowledge, not just decision traces, execution traces. You ground it in fact. The other thing I'm asking is that yes, the framing is beautifully simple. It's beautifully simple and very enticing. But when we actually get into the work, and I think we're going to see this with later presentations, there's a lot more involved. So when we look at what actually procedural knowledge entails, elicitation, defining, building engaging the humans, and realizing that context is not a technical problem, it is a knowledge problem. That's why they're called knowledge graphs again. It's knowledge management. So I'll leave you with this, and this is, I indulgently included my own quote from my paper, one of my papers, which is, you cannot manage what you do not understand, and you cannot understand what you have not bothered to document. This is normally considered the boring stuff. I think it's the most exciting stuff, because it's the way you become intimately familiar with your business. It's the way that you really understand what you're building, and it's the way that you can derive value from the systems that you build and that you present to AI. So, in my opinion, it was never boring at all. And that's it. Thank you.
Thank you so much, Jessica. That was incredible. And we're so appreciative of being able to have an honest conversation of context graphs.